all the time, all the time. Math is what explains the world, is one of the answers of what is math. I just did a test with about 40 kids, and it was simply on math facts. And it was very interesting. I asked them if they liked math. Out of 42 kids, 39 of them, without hesitation, said yes. The three, none of them said no. The three of them hesitated and kind of went, eh. They were also the three kids with the highest scores. I was stunned, and then my first thing goes, you can bore kids, and I would never use the word bore in front of a child, but I said, oh, are you not challenged? He said, no, that's not the problem. And then I asked him, and he goes, well, I know my multiplication facts. I said, cool, what do you know? And he said, 5 times 4 equals 20. I said, great, what does that mean? He goes, I have no idea. And then my thought was, of course you don't like math. You're kind of being pushed, because I can tell you that's not happening at school. That's coming from home. I am going to invite you to at least come up one table. So what can we do with our kids? Encourage them, math puzzles, math games, and especially at their age, constructing things. And there are fabulous games on iPads and computers. And I went to work with some 5th graders, and we had blocks that didn't have interlinking things, and they were surprised that building past 5 they would fall over. Your kids need to be doing them with real things, because they don't fall over on iPads. In the real world, they fall over. So on the front of your packet, this is where I'd like to get off my recipe. I would like to show you, sorry, I gotta get all this closed. I gave you 3 sites on the very front page. And it's not very smaller, that's interesting. So this first one is me. If you have any questions, you're welcome to write me. The second one is math games. And this is simply a list of games that you could be looking for or playing. They're going to pop up soon. But we literally made how you can buy them from Amazon. I have no stock on Amazon. It's just the easiest way to give them to you. But also, get them building things, because it's one, they have the whole kinesthetic. It's also great for problem solving. And you know what? This is engineering. We put a fancy name on it. We're calling it STEAM now. This is engineering. This is the beginning of it. The engineering and the problem solving that comes from building these type games comes from the same region of the brain where calculations come from. So this is what we do in pre-K for problem solving. They don't do numbers yet. So if you go to this website, it'll go down and down and down. I just think we've gotten away from these type things because iPads are really cool. I think so too, but they each have a time and a place. And I hope you're reading about the amount of hours your kids should be in front of screens, because it really should be limited. Not nothing, but it should be limited. So I wanted to give you the general games that you could be doing. These would be great things to be doing with first graders over the summer. The next one is a very particular math facts sheet. Your kids, by the end of 1st grade, should know their math facts, their addition facts to 10. I can tell you, having just interviewed 42 kids, practically all of them know their facts that equal 10. 7 plus 3, 5 plus 5, 2 plus 8. They know those. What they don't know, or they're less confident in, is the 3 plus 4. It's kind of those ones in the middle with the answers between 5 and 10. They know 2 plus 1, they know 2 plus 3, they know the lower end. But that group of 5 plus 4, 5 plus 3, those are the ones with they're just not quite as confident in. And really we need them, it's appropriate now, because we've played all the games, we have built them, we've given them multiple strategies, and if you were here at the beginning of the year when we brought out all the cubes, I said, please, we will get to them to the point of they should know automaticity. These games, I'm going to close this because she gets tired of hearing me. This one in particular, give yourself 10 minutes if you turn it on, because I get, even adding to 10, I still get stuck in it. They have a bit of a time component. We don't want you sitting there with a stopwatch, but we do want them thinking and getting efficient in their thinking, not always pulling out their fingers. But these games make it fun, and so they see 3 plus 7 multiple times. So they may not get it right the first time, but they've seen it the 4th time and the 7th time. That's what they're ready for. They're ready for that. We call it automaticity. Is it memorizing? Yes, in the general world, it is. I can argue as an educator why I would use a different word, but we're getting cranky there. What I would like to do is, these are fun. Here's your iPad time. These are online facts. Sometimes when you do them on the iPad, they behave a little bit differently. What I want you to say is this should be, not loud, but this should be an out loud game. The way the brain works, this particular game, I think they're supposed to be adding to 10. There's all these numbers, and if 3 comes up here, you shoot a marble trying to hit 7. They should be saying that out loud. When the 3 comes up, they should go 3 plus 7 equals 10. Not just 10, that's an isolated fact. We're trying to get them to understand the connection there. So they're doing it silently inside their head. We know that when you speak, it takes a different path. But this is that idea of giving them flexibility and giving the brain flexible ways of getting to the answer. So all of these games, as they're playing them, you should be hearing them making this statement. And the game is not going to ask them to. So that's going to come on to you to ask them. I have opened all of these in the last 6 months. These games, your kids are kind of the youngest, so they should be selecting easy. And you'll probably have to set them up the first go round. You should be selecting easy or slowest. Some of them you even pick which sums you want them to go to. But be aware that they may quickly, if your children are getting frustrated because they're getting too hard, that could be. After 3 or 4 rounds, they might be bumping up into 2nd grade facts. A lot of them are ready for the 2nd grade facts, or they're going to know some of them. They do conceptually understand them now, but I would imagine some of these games might even go into 23 plus 42. I don't know exactly. But this is a fun way to put a lot of repetition. This really is the old way of drill and kill. Now it's fun. I love that one. I love this one. This one to me got fast in a hurry. I'm like, ah! What's really nice about this one is that you can put any combination together. So for 10, I could put 5, 1, 2, and 2 together. That is fabulous flexibility. So if your child knows them easily, this is a game. Can they see multiple ways of adding them up? I can't speak to each one right now, but they're a good set of games. And that is on your sheet, the fluency games. This will be online. Well, all of these. I think it's probably just as easy to put that in the Google search and you'll find it. So I'm going to ask you to have fun with your kids, play games and puzzles. Joe Bowler makes us, what do I do? Or do I have to unplug?
No, you're pressing the home button.
Oh, I can fix that. There is this comment of don't tell your children they're ever wrong. I think that can sound wrong because of course kids need to be able to know when they're wrong and they're right. But the idea is that a lot of times when kids make a mistake, telling them or showing them where the mistake was made is far more beneficial than you're wrong. You're wrong doesn't really help them correct it. So I have no problem with telling a child no, I don't have a problem telling a child you're wrong, but really what I want to do is support them in their learning. So I think this is, they say 3 by 4, they immediately said 7. Well, it was a multiplication problem. So I understand what you did. 3 plus 4 is 7, but that's not this problem. And that's how you talk that through. And accuracy is a big deal. If they said, if it was 3 plus 4 and they got 6, you can say, oh, I can see that you added, I just don't think your answer was accurate. So there's just ways of encouraging them to get to the right answer instead of, the technically red pen marking it wrong. Never associate math with speed, and yes, she's British, so it's maths. Especially the stopwatch or the on-demand. Yet we've got these games that can put speed into it, and they're not overly noticing it. And I spoke to this, especially moms. Nobody's bad at math, don't talk about it. Tell them you're willing to learn it with them, but we can all learn it. Yeah, this idea of number sense, this is the way we teach at our school. It's that idea that you've got to be flexible, you've got to have multiple ways of doing things, you've got to look at numbers, and we're going to talk about this in a minute, and see strategies, pick a strategy of how to solve it. It's not just one way. And the growth mindset, which is all over the internet, is just that idea is that we're all capable of learning. And we are. All kids are capable of math. Yes, we can go at different speeds. Yes, we may ultimately end up choosing different strategies because of our strengths, but we're all going to get there. Okay, let's get to the real first grade math. Quickly, could you look at the next page? I just gave you some vocabulary that I'll probably be using today. It's been used all year. This isn't something new, but nor is it going away. This will be part of their conversation for the rest of their life in math. Some of it gets more sophisticated. The tape diagram, all these things, these are just names of strategies, and when they have a name, it's easier to explain to things instead of talking out each, I drew 2 sticks. You can say, oh, I did quick tens, and we all know what we're talking about. So these 3 in particular, they're computation strategies. You're not going to find them online under a math definition. They are not properties, they are not rules, but they're just language that we have that we can talk to the kids about math. Okay. Your kids have really been introduced to working with past 10 or past 20. They're now they understand that a 10 is a group of 10 ones. And so then we get them thinking about, well, I can add in groups of 10. I don't have to go back and add everything up one by one by one. That's actually a big move. I put manipulatives on your desk. Most kids no longer need them at this point because we've taken them to a representational stage. Can I ask you just to move up at least to here because there's stuff. And so now we're getting this idea that they can do 10 more, or 1 less, or 1 more, with an understanding. So they are being asked, 10 more than 39 is. Well, I know that 39 is 3 10s and 9 1s. I want 1 more 10. Well, if I was struggling, I might actually draw this out. And if I want 1 more, I need to draw 4 10s, because that's 1 more. And my 1s would stay the same. So it's just that thinking in terms of place value, not always adding on. 39, 1 less, okay? I'm only talking about the 1's digits. I can take 1 away, and I would get 38. I could draw these, and 1 less, I would take that away, and I would be able to count it up. The vast majority of kids are not drawing these anymore, but they do have the skill to do it if they had to verify their answer. Quickly, I know if you've been with me, you'll know some of these things. We know that the brain sees in patterns. I highly encourage kids to draw things that look like the 10 frame or 5 and 5, because our brain can see. I mean, these kids are so used to this that most kids can look at and go, 2 are missing, that's 8. They don't have to count them. They use them lots and lots. So as I encourage kids to do that, if they don't do it, I let them go unless they're inaccurate. If they're inaccurate, they don't have a good strategy that's working for them, I am going to make them start using that 10 frame looking thing. And it can go vertically or horizontally. Okay, so this is what quick tens is. Literally what we say. So it is a way of understanding how to add bigger numbers. So I can do 42 and 50. I'm just drawing all of it. I can now count it up. I know that that is 92. I know to put tens together and ones together. I'm also going to tell you I put lots of problems on here. I'm probably going to pick 2 to do of each type, just to make sure we get through them all, and then we can come back and look at others. So 30 and 57, same idea. What I'd like to go down to is 26 plus 54. Would you go ahead and solve it? Remember I said we need to know our tens facts? Excuse me. Okay, would you turn and talk to your table mate? What did you do?
I had the tens and the ones. The example. I had the tens.
And how the kids actually work that becomes a little bit
That's okay. So, right. Maybe that's the way
we talked about, we've got these 10 ones sitting, we've got 6 ones and 4 ones, we put them together, that's called composing. They do equal a 10, so I made a new 10, and somewhere, I'm not sure how the teacher would have them do it, they crossed the fact out that they turned the 10s into, the ones into a 10, and now I can count them. I've got 10, 20, 30, 40, 50, can't see that, 20, 30, 40, 50, 60, 70, 80. So I've got an answer of 80. If the problem had been 26 plus 58, I think a lot of kids, what do you think a child would do? Yeah, I think a lot of them would take the 2 5s. 5s are a very friendly number. They're going to move on. 5 used to be the friendliest number to them. They're moving on to 10 being the friendliest number. But they know that 2 5s are 10. So I've got another 10. I still have 4 out there. So I have 10, 20, 30, 40, 50, 60, 70, 80, and 4 more. And they may or may not have. They may have combined 6 and 4. All of that's up to them. And that's where we let them make their own choices. So this is called quick tens. By the end of first grade, most kids are very, very adept at this. In fact, it's the one that we've started saying, well, let's move on from this. So moving on from that, what does it look like? These are the kids, they're understanding the quick tens. And so we start decomposing by place value. That means I make 29 be 20 plus 9 plus 40 plus 2. Now I'm going to go back to my quick tens. I wish I hadn't used the number 9. And this would be how it's taught. Can you see 20 plus 9 in my drawings? Here's my 20. Here's my 9, here's my 40, here's my 2. I'm just now understanding numbers enough that I don't have to draw it to be able to see it, that I'm understanding that these numbers are represented this way, and now I understand that I can do it with just numbers. Now, how am I going to add them? I'm going to go by place value, so I'm going to put 20 plus 40 together. And this, they probably count up by tens. They probably go 40, 50, 60. And then I have my 9 plus 2, which equals 11, which is not a great one to start on the very first time with them, but they're now capable. So I have 60. A child might break this into 10 plus 1. Depends on the number sense of the child. So 60 plus 10 is 70 plus 1 equals 71. The step from the page before to this one, we would have done multiple days of having both the representation and the numbers. I'm moving you guys along faster. So please don't go home and try this tonight, because your child might not be there tonight. Looking at these, let's do 69 plus 26. How would we break it apart?
60 plus 9 plus 20 plus
60 plus 20 equals 80. 9 plus 6, again, it does equal 15. And a child might look at it and say, for me to understand what to do, that's 10 plus 5. And that is absolutely the reasoning we want them going through. So now, it's 80 plus 10 is 90 plus 5 is 95. So I do want to show you, once they get here, they may also be doing 60, 2 jumps to 80. Here's my 20, and then I jump 9 plus 6 is 95. So this Can you read that? Or am I just from the side? Okay, so this is a straight numerical way, but we have a lot of tools to help us. And that number line, we call it an open number line. We don't put all the little hash marks. We make our own decisions of what we want to jump. I want to do this again. I might have done 60 plus 20 equals 80. Plus 9 equals 89. Now, this going, we call it going across a decade. The next one might be hard for me. It's plus 6, so maybe I'll just do a plus 1. I get to 90, and then my plus 5, and I get to 95. Yep.
It's not necessary here, because it's a line, to have a line from 0 to 100 with a small line. No.
Yeah, no.
It's,
We call it
that
a
it might be more clear for them.
They've had a lot of that at the beginning of the year. But here with these numbers, you're not going to do all those ticks up to 60. And
No.
they really are capable of now understanding that 60, there are 59 numbers before them, in front of that.
Yeah, but you start the line from 60.
If a child was having trouble with it, yes, I would give them a longer number line. Most kids probably aren't going to have that problem. I also would like to show you that if this problem had been 26 plus 69, they would have started with the 69 anyway. They've done a lot about starting with the bigger number and adding up. So I think there's been a lot of discussion that way. For sure, I would have that discussion if anybody was looking lost. I don't think that's a common problem. And in fact, I might, the very first one, I might do that with a long line, and then we can make it pretty exhausting for kids to go, why don't we just start at 60? I would like to do 31 plus 48. I want to show you. It's called the arrow way. There are people who love it and people who are ambivalent about it. I refuse to let them say they don't like it, because mostly it's because they haven't tried it. But it's this idea, it's a lot like a number line, but we can go up and down in any way we want. So I would just do 30 plus 40 equals 70, plus 1 equals 71, plus 8 equals 79. Trying to think of The rationale for it, which we're not doing with first graders, but what I'll show you, is I could have done 30, let me think this through, plus 40 equals 70, and trying to do, well, let's do the plus 1 is 71. They wouldn't really do this, but they might do a plus 10 is 81 minus 2 equals 79. I didn't make it easier, but it's this idea that sometimes they can add up a friendly number, but it's too high, so they take it back off. This is a bad example because I didn't help myself. I actually went across a decade. But that's the difference between a number line and the arrow way, is that the number line, to me, is stream of consciousness thinking. We've given them a way to write it down. This tends to be kids who say, I just know it, gives them an opportunity to explain what they actually did in their head. Because this is mathematically correct. Most of those kids would say 30 plus 40 equals 70, plus 1 equals 71, plus, 8 equals 79. That is an absolutely incorrect mathematical statement. So this is just giving them some notation that's correct that they can use. And the reason this is wrong is because this does not equal that. And this is a really common mistake among our bright students who just don't have the notation skills yet to explain it. Because otherwise this becomes a series of these problems all the way down. And in first and second grade, that's not reasonable. So I was introduced to this 4 years, and it was a huge aha for me, and all of a sudden I was able to help those kids who were just saying, but I just get it. It's like, yeah, but you did something inside your head. Try this. We don't make any child use it, and I've had kids who struggle in math say that it was the best thing that ever happened, and I've had really high kids who didn't like it. So it's kind of one of those, this is the thing about teaching strategies. Some of them work for some kids, not all kids. Some strategies we need to wean the kids off of, such as counting 3 plus 4 on your fingers. Perfectly good strategy at the right level, but we need to get past it. This is a notation. We give it to them, we practice it, but we don't make anybody do it. I don't really make anybody do the number line, but again, we will practice it to give them the opportunity to learn it to use. Okay. Use decomposing. So we just decomposed our numbers by place value. Now we're going to be more,
Just have a quick question before we move on. So in saying that you would encourage them to do this arrow way as opposed to, are you basically saying don't have them break it down like we did in the previous problem?
I'm saying it's simply a different notation. Both of them did the same thing.
So
I'm going to have them practice all 3 ways, and they're going to gravitate towards one. What will happen after time and me knowing the students, when I see a child who keeps making a mistake here, I'm going to say, this one's not working for you. Let's try one of the others. Otherwise, I don't care. These 3 are all equal, as I'd say, on a status line. There are sometimes as I said, we wean kids off of fingers, but these are all of equal value. So if you see it that way, great. This is not the preferred way by students. It's a lot of work in their minds. It's very algebraic, we like it, it's great for them. More kids probably gravitate to these 2. Okay, now we decompose by place value, which makes a lot of sense, but sometimes isn't the easiest way to do it. Now I'm talking about decomposing to be able to make 10. And I'm going to back up and show you 7 plus 4. At this point in first grade, that is not necessarily an automatic fact. So we have taught the kids, what do you know? You know your facts to 10. 7 plus what equals 10? Can I break 4 apart and find me a 3? Yeah. So we're back to our number bonds. 4 is 3 plus 1. Now I can add 7 plus 3 is 10. I've got 1 more, and I've got 11. They have been doing this since October or November in these sorts of numbers.
Wait, is it 7+4 or 7+3?
Yeah.
3 plus 1 equals 4.
No, but it's 57 and 43.
Oh, I'm sorry, no, I was just showing you.
Oh, okay.
I'm sorry. That was pure coincidence. Actually, I know how the brain works. That wasn't coincidence. I did not pick those numbers purposely, but my brain saw them.
You saw it, yeah.
That was just to remind you that this is what the kids have been doing all year. Now we can take the same strategy and we can apply it to larger numbers. And when we can do that, all of a sudden, these are going to move into being mental math instead of paper pencil math.
What's amazing about this is that we end up talking about it in the car, and I'm amazed that he can do it in the car.
Yeah.
Just random things like how old are you, how old is dad, how old are you together? And then I say, well, how many tens are there? How many ones are there? And then he can just sit in the back seat and he can do it.
That's fabulous. Get him to give you a problem and get him to ask you those questions. Then you know he's got it solid. Because how fun would that be to say, okay, I don't know how old you guys are, but dad is such and such and I'm such and such. Help me get through this. And him to say, oh, how many tens are there? How many? That's just great. And that's what this does. Because when I was raised, that was a paper pencil. I would have had to go get a lined piece of paper, turn it this way, line them up directly, make sure I got my carrying mark over, and if I didn't do all of that, I was wrong. And it really stifled us. So what can we do here? 57 57 plus 43. Can I get these to easier numbers? Absolutely. I'm going to show you, I break apart the number, not by place value, but by what makes this easy for me. It doesn't matter. But I'm going to show the kids that strategy. So instead of writing 40 plus 3, because I want the 3 to go with the 57, I now have 60 plus 40, and that is actually 6 tens plus 4 tens is 10 tens, and that equals 100. So arrow away. I can do 68. I want 2 from my 32. I get 70. I have 30 left. I get 100 also. $48 plus 23. And they might do this. This might still be needed. Depends where they are. 48 plus 23. How many do I want to make my 48 an easier number? 2. So I've got 48. I do plus 2, I get 50. I'm going to break my 21. Let's break it into 20 plus 1. A lot of kids wouldn't need to do that, but they might. And I get 71. So lots of different notation for that process that's going to, after practice, going to become somewhat of a mental strategy for them. Not in first grade, but they're moving that direction. $27 plus 67. Which one would you like to make? Now, and we talked about this. We're getting these to a tens number is what we call them. So we went to 50. On this one, we've got a choice. We can go to 30 or we can go to 70. We've taught them so much about it's easier to get the bigger number first that a lot of kids are going to say, fine, I'm going to break apart the 27. I need 3. So now I know it's 70 plus 24. And because these are tens numbers, a lot of kids are going to be able to say, oh, that's 94. Or that's our end place. They'll get fluent in this in second grade. Right now, they're probably thinking it through quite a bit. But we're taking this skill that they learned way back in October and extending it. And then I'm having my fourth grade teachers come down and see it because it's actually how we decompose fractions, and 2 3/4 plus 2 1/2 becomes an easy problem because we can decompose and get to a whole number. So all these strategies that we're teaching, the keep aiding the math as they get older and older. Does that make sense? So we are still doing word problems, because really that's what life is. We don't walk into grocery stores and get presented with 3 plus 4. Thinking is so important, and explaining their reasoning is important. So you see these on their assessments. Can they problem solve? First grade problem solving is, can they take words, we call it mathematizing it. Can they take a picture, can they take a story and turn it into a number solution? One of the biggest problems that somehow around the world, I don't have to read this, I see 14 and 8 and I know I always add, so I get 22. Except that that's a subtraction problem. So, reading becomes critical. Let's go back to the first one. It does happen to be an addition problem, that's why I pointed that on the second one. But if I know that Nikki has 12 cars and Willie has 4 toy cars, when they play together, how many toy cars do they have altogether? At the beginning, we would have put out 12 cubes, and we would have put out 4 cubes, and then we would have put them together. We still have some kids that need to do that right now, and that's fine, because they've got the skills to do it. Those manipulatives will be on their desk in some form through at least 8th grade at this school. We move them on from it. Most of the kids have moved on. Some of them are still going to do something like this. We've gotten them, they're not drawing cars, we've gotten them to symbols, but they've put the idea together. Well, we can do this. This is what we call our tape diagram. Here's our information. This is Nikki's 12 cars, and this is Willie's 4 cars. Well, I didn't give myself space. I should have given myself space to put, and I wonder what the total is. Many kids now can now say, oh, we had 12 cars and we have 4 cars. And this is the life of every classroom. We've got kids at all of the stages, and we're meeting them where they're at. And we're moving the group that had to use from the manipulatives to try to get them to this drawing. When we get them to this drawing, we're saying, do you really need all of those to count up anymore? If so, go for it. Some kids are very happy doing this. But this tape diagram should tell me the whole story, so it needs to be labeled. And we care a lot about this. So we need Nikki, we need Willie, we need to know what the question is. Because that's what helps us to know to add, instead of on the next one where we might have subtracted. So now, can I add it? 12 plus 4 equals 16. The boys have 16 cars. And this should say cars over here. This is called an answer statement, and it has a lot to do with going back and making sure we're actually answering the question that was asked of us.
And should they just know that as a number fact at this point, the 12 plus 4? Or are they
No.
going to further break that down and write it?
Yeah, and we're going to be all over the board on that.
Okay.
Most of them are probably going to do 12, 13, 14, 15, 16. Some of them can do it in their head, some of them are going to do it on a number line. But as a number fact, no. I mean, I would say most kids aren't even close with that.
As far as showing them
So-
that this is okay though, just to.
Right, and yeah, they would probably then, I mean, I think a lot of the kids would still be here and they can just count it. Some of them might break it apart. I'm not sure how they would really show that. Because you're right, this really shows that they're understanding the question. At this point in the year, I think they're expected to be writing that as a statement also. 12 plus 4 equals what? And then we're kind of generous because we do know that kids can count on in their head at this point that they would go 12. They might do it with fingers, but they can also do it in their head. Now, 12 plus 9, they're not going to be able to count on in their head. So we have that huge gamut. And we will for the rest of our lives in the classrooms, and that's fine. We know they'll get there, they just don't have it yet. The next one, Tamara has 14 grapes, she ate 8 of them. And they might even make a break at 10. 5, 6, 7, 8, 9, 10. I did count. So she's got grapes. This is Tamara. She's got grapes. And what are we gonna do? She ate 8 of them. What did she do? Oh, she ate 1. She ate 2, 3, 4, 5, 6, 7, 8. So this one is kind of more obvious as to how they get the answer. But I would still want 14 minus 8 equals 6. Has 6 left. So if she went back and she had added these together and then tried to go back and write that answer statement, that should be a last check to help them see that they had solved the wrong question. There are kids who will still do it wrong because they're not reading carefully. Lee found 15 sparkling rocks. Kim found 8 sparkly rocks. How many more sparkly rocks did Lee find than Kim? This is a comparison problem, not a takeaway. It's a completely different story, and we set it up differently. So we have this is what Lee found, but Kim found 8. This is the how many more. We're comparing how many Lee had to how many Kim had. I want to know this area. If I had drawn this really accurately, which I should have, I can put a line there and say, oh, 1, 2, 3, 4, 5, 6, 7. Lee found 7 more. Can this be done without it? Without drawing the numbers? Absolutely. This would now become 15. This would be 8. And this would be the same question mark. And the way we progress is, as I said, we might have done it with manipulatives first and at the beginning of the year, absolutely. Then we draw it with the manipulatives right in front of us. So a child here, I would also ask, why don't we draw it? What would it look like just with numbers? Knowing full well this is the way they're solving it, but I'm encouraging them to move on to the numbers to understand the problem. To solve it, they still may need to do this. Or, now we've got, this could be 15 minus 8 equals 7, but this also could be 8 plus what? Equals 15. Oh, thanks. So we don't call these subtraction problems because we can always add up. I'm sure this is repetitious to some of you, but as soon as you call this a subtraction problem and you've got a child trying to add up, you've just thrown them kind of under the bus because they don't see it that way. And that's a struggling child. A child who gets it is going to see the comparison and go with it. I'm, at this point, worried about that child who didn't see it that way, and now we've lost them completely. We would have a discussion in class. I want the child who did it this way to explain it, and I want the child who did it this way to come up and explain it, and then we're going to talk about what's the same and what's different. And that's that understanding that we didn't used to go for. It's far better to do one good problem and talk about it and do all this and then do one more than 16 of these problems over and over again, and some child just did 15 of them wrong. So this is the difference of our classrooms. Now, to challenge some kids, we've got the next one. Shanika did 11 cartwheels during recess. Kim did 6 more cartwheels than Shanika. Well, Shanika did 11. Kim did 6 more than Shanika. Well, I know how many Shanika did. And Kim did 6 more. How many cartwheels did Kim do? Kim did 17 cartwheels. How do I know that? Because I added 11 plus 6, and I got 17. And I might want to explain where I did that. I'm going to break apart the 11 into 10 plus 1 plus 6, and I see that that's now 10 plus 7 equals 17. Then I want to know how many they did all together. And this becomes questionable. I, as a teacher in upper grades, would never have them redraw this. I'll be honest, I don't know whether the teachers in first grade make them redraw it, but they might say, okay, this was Shanika at 11, this was Kim with the 11 and the 6, or that might still have been 17. And then I can add 11 plus 11 plus 6, or 11 plus 17, and get an answer. And in my class, easily half the kids aren't going to get to this particular problem. But I need to have something on hand to challenge the kids who are understanding it today. And they could be using the number lines, they could be using the arrow method, they could be using the drawings of the X's and O's. All of those things will start coming up. Or kids who are completely understanding this but getting the wrong answer, we have them do it in 2 different strategies. It's what accountants do. They always add it up twice to make sure they get the same answer. That is a way of proving that your answer is correct. Doing the same strategy twice, you are actually you're likely to make the same mistake twice if you've made a mistake. So that's where we want them to see that using 2 different strategies, you're thinking about it a little bit differently, and it can help you catch errors.
So I see the relative importance of making the student write the statement at the end. But if the instruction is to use the tape diagram, shouldn't it be, they're saying that they should be using other strategies, but they have to show that they can use the tape diagram in the problem, yes?
The tape diagram helps them to understand the question. And in first grade, especially like here, it also helps them solve it. At this point, a child could get this tape diagram correct and still not know how to add those numbers together. So the tape diagram is a way of explaining that they understand the question. They then have to go on and do some calculation to solve it. On a test, this is called a model.
Right.
On the test, we don't tell them which one to use. But I'm gonna be honest. All throughout the unit we will, because if we don't make kids try new things, they'll keep reverting to their old, and sometimes we are moving them along this more efficient path. There are a lot of models out there. Tape diagram works about 95% of the time, so we use a lot of tape diagrams. It's kind of almost not as important here because number bonds would work for this also, and I probably should have been modeling that also. Tape diagrams by the time you're in 5th grade are an absolute hallelujah. I got a way of explaining these things of 1/4 of my time and then 1/3 of what's left and then +2. So they're great. How they solve it, all that notation is up to them. So in the middle of a unit, they may take, we call them check-ins, and it may say you have to use a number bond. It might say you have to use arrow way. On the final assessment, they get the choice. I'm trying to think of, there's one standard in 3rd grade that says they have to use the area model. Very rarely do our standards say what model they have to use. So they do have to model it somehow. And first grade's a little bit unique that if they are solving it this way, even without the squares around it, you've got a model. 12 plus 5 is not really, an equation becomes a model when you get to higher math, but in lower math, it's not considered a model because of the research and because of the way the standards are written, we want a representation, a visual representation of what it means. Was that a long answer to your question? So, I want to tell you, this is the end of first grade. And we'll have kids who really struggle, but they'll still really be at this level. And you know what? Good for them. They're there, they've got a strategy to figure it out. But we have those kids who are just soaring along also. But I want to let you know what I've shown you, we kind of call it that +1. This is where we're really pushing them. Help your child make sure they understand that they can draw it out, and that they have to. Writing the answer, which one was this, 12 plus 4. If I just got an answer of 16, they have not communicated their reasoning, they have not modeled it, they have not justified their answer. They would get a fairly poor mark, and on that they would get it right for problem solving, and they would get a very low score on all the rest of the things. Just getting answers is no longer what mathematics is about. And I had a man sitting here who walked in and I thought, oh, he's going to be my biggest problem today. And at the end he goes, if I walked up to my boss and said, here's my bridge, trust me, I would be fired. And that's kind of the mindset that we're getting into. Great, you know the answer, prove it to me. So it may seem a little tedious at this point for kids who are hyper-focused, and it is, some of it's put in their head by adults, but some of it is the kid. We start giving them the answer and say, prove it to us. And it's funny, all of a sudden it's like, oh, fine, now I'll do it. So we're just getting in that whole thing of the explanation, prove it to us, because it sets them up for when the problems get harder. And they will eventually get harder for every single child. But we're at the beginning of this stage. So I'm going to part with, play the games. They really need to know their number facts up to 10. And kind of remember that they know the 10s pretty well. They know the 5 plus 5. It's those ones, the equaling of 7, 8, and 9, they tend to be weaker in. If you play games with them, I still go back to let them ask you questions. This isn't a one-way street. If you want to play games, but just don't do any of this, what's the answer, what's the answer, what's the answer. They know it, the chemicals freeze, it goes down to brain. And I even pointed out, one of the games got fast for me, and I noticed, I really do know how to add to 12, and I was making mistakes. I'm like, here's proof of what's happening. I'm panicking over the time. So I think those games are great selection, but if you see your kid, if the time is doing it, that game's not for them. Other kids will just delight in it, and kudos for them, whichever way works. But relax and enjoy and build. Go outside if you're not in Doha. Sorry, some of us leave. It gets to be that temperature. Any other questions about grade 1 or grade 2?
Yeah, I have a question. What do you do with the different level of or ability of knowledge in the same class? I mean, you said before that a few of them are still struggling to be in that point. Others are not. So those kids are in the same class. I mean, what is your strategy?
And they will be from now the rest of their life. You know, I mean, the truth is. I mean, this is, the short answer, this is what we're taught to do. Some of them, I should always have that extra problem to challenge those kids. And some of them, honestly, will still get through that very quickly. I have, at that point, I do not teach them second grade standards. That's for the second grade teacher. But I have puzzles. I have especially spatial puzzles because we don't tend to do a lot with that. I have that one game that I showed that was like, it was 12, but I could add 2 plus 3. I'm not going to be able to keep up with that. 2 plus 3 plus 3 plus 2 plus 2. That is a real challenge even for our challenging kids. So teachers have those on hand. They have all those extra things. A lot of kids who look like they're very far ahead have a lot of trouble being able to explain this. So I want to make sure that they are well-rounded in that further knowledge. So that's what we are balancing at all times. So yes, sometimes I'm making them do some problems that are easy for them, but I let them get through it easy and I have the next thing for them to do. And it's not go read a book. It's something mathematical and it's something challenging. I mean, we have challenge notebooks and they have all sorts of magic squares. So they're more logic and spatial are the two areas that we really try to beef up for those kids. Ken-Kens, and some of these, by first grade, by the end, they could be doing them, but honestly, they're too young to be doing some of these. I know they have the game Set, which is about finding cards that match using 4 levels of things that have to either completely match or not match, so we're playing those sort of games with them. There's also, for the lower end, there are teachers who also help us. There are second teachers that come in and help. We just have to be real careful, because I had that child telling me 4 times 5 was 20, and all it was a flashcard. They had no idea what it meant. I had another little girl last year who told me, we were trying to figure out, it was odd, 7 plus 7 is 4, it would have been 14. And a little girl raised her hand, she goes, I know 6 plus 7 is 13. I'm like, great, because that was kind of a weird one to know. And how can you use it? No, 6 plus 7 is 13. I'm like, how do you know? She goes, I can see the flashcards. I said, great. How does that help us with this problem? I have no idea. So we have to tease out whether the child knows a lot of isolated facts because I'm not a fan of Kumon, because they've gone to these tight places, or they've played games and they've picked it up. So I do have to tease out, do they truly know, are they flexible? And they are. We've got bunches of those kids. And it's not just 1 per class. We could have 6 or 8 of them in a class. So we start having them work together. We start having them doing challenges. So it is what we're taught how to do. It is what teachers go home and worry about every night, that they're challenging each kid.
So it's like you work individual with every child, isn't it?
Well, it's kind of funny.
At the same time all together.
But they do kind of lump into groups. A lot of teachers will have centers. I know a lot of teachers teach a lesson, send a good portion of them off to go work in partners, because if they're talking about it, it's better, and keep 5 with them, because that 5 needs to do it again and again with them.
So there are groups in the
But they're fluid. It's like we use a lot of whiteboards, so I watched today's lesson and oh boy, you guys are really good. Would you 4 please stay here with me on the carpet? And then I invite anybody else who wants to stay with me on the carpet gets to stay. But it's today. I'm not even really taking formal notes that I worked with this for, but I am kind of intelligent and can remember that so that I check in with them tomorrow. And you guys did fine, and then I come up around, because I don't stay with them only, because everybody deserves me, and I walk around and say, ooh, they didn't quite have it either, and that's the group I check in with tomorrow. So it's a very fluid thing, but it's not groups. We don't give a test and say, you 4 are in the famous one is you're the eagles, you're the bluebirds, and you're the pigeons, and we all know that eagles are better than pigeons, but we don't do that. I mean, let's stop there. Pardon me?
She pigeonholed them.
Yeah, I did. Exactly. And we know that you can not get it. Come on, think back to the days. Can you remember when you got back that test that you didn't do well on? They went over the answers and you went, now I get it. You just needed that one more day. We know that learning, it happens over time, and we are not all on the same calendar. By 5th grade, we actually give tests over again a week or 2 later, when we've given kids time to relearn some stuff, because now they're pinpointed and they understand where their learning needs to occur. That's way too sophisticated for 1st grade level. Thank you for coming.
Thanks, Carol.